Hello, security pros, and thank you for joining us for today's ESA webinar. Stop using POTS, communication pathways that offer transmission reliability, enhance RMR, and meet code. In this webinar, we will discuss the underlying problems with POTS connectivity at all levels of communication, the symptoms being felt today, and how regulatory changes are impacting the adoption of alternate technologies. We will also take a deep dive into the alternatives that have been used for years, how they have evolved, and discuss some of the new entrants that have begun to flood the market, taking advantage of the pod situation. The goal of this presentation is to get a clear understanding on what the environment looks like as we enter the second half of 2023, what the proper alternatives are, what other options are being used that may cause issues in the future, as well as what actions we, as dealers and integrators, must take to ensure the safety of our customers and growth of our RMR. So I'm Daniela Chavez, ESA's Marketing and Communication Specialist, and I'm excited to lead you guys on this webinar today. But before we dive in, I'd like to provide some tips for those of you joining us on your first ESA webinar. You will be muted for the duration of this session, but that doesn't mean that we don't want to hear from you. If a question or comment comes to mind at any point during today's session, click the Q&A icon at the bottom of your screen, and I'll ensure that we save some time for your questions with our experts today. We also will be recording this webinar so you can rewatch the on-demand session and share with your colleagues on our ESA YouTube channel. If your company is a member of ESA, we thank you, and we hope you're utilizing your benefits to save, expand your team, and get connected to the ESA community. If you're not yet a member of the Electronic Security Association, check us out. ESA is the largest and longest standing association serving the pro-installed electronic security and life safety industry. Our members are integrators, dealers, monitoring centers, and even manufacturers and service providers in the space. You'd be surprised at the power an ESA membership holds for your company. Get a feel for all of the ESA benefits, including savings on business insurance, training, customized in-house onboarding and professional development programs, peer networking groups, government advocacy programs, certifications that satisfy state licensing, and in some cases are also alternatives to NICET at esaweb.org. One of our membership specialists would be happy to walk you through these benefits in the application process. We at ESA realize your time is valuable, and we appreciate you spending some of that time with us today. So without further ado, I'd like to introduce Daniel Rosales. Daniel has a degree in computer engineering from Florida Atlantic University and an MBA from the University of Georgia. As a director for Telguard, Daniel oversees technical support, product management, and marketing for Telguard, which allows him to not only stay in tune with the current state of the industry, but also stay informed on the latest technological developments to improvement. Daniel, please take it away.
Thanks, Daniela. I appreciate the intro. So we'll try to make this as concise and as brief as possible so we can get to any kind of questions that may come up. Let me go ahead and turn off my camera just to make sure that the feed is as flawless as possible, and I don't scare anybody away that joins late. So today, Telguard, we have been, I guess, labeled, if you will, in the industry as the alarm communication experts. And it really is because we have been around for such a long time. We have been in the industry for almost 4 decades. And our focus has been the alarm communication space, whether it's on the intrusion side or on the fire side. We've been there, we've done it, we've been through every single sunset on the cellular side, and we're currently very much in tune with what's going on from a communications perspective, not just cellular, but whatever else is going on that will impact the industry. So again, this is me, my picture. Don't need to see that again. Today, we're going to talk a little bit about who's Telguard. You know, why should you believe anything that I say? Why should you trust that we have the expertise? So we'll dabble a little bit, a couple of minutes on that. We'll start with the problem today with POTS, the problem that has been sort of brewing really for quite some time. It's been building up, and now we're at a point in time in which it's very, very much a call to action for integrators, for security dealers, for anybody in the industry to take note of things that are happening underground for things that are happening from a federal perspective that are going to influence the way that our end users, our eventual customers, right, our direct customers, will look at communication pathways for their systems. We'll talk a little bit about the LTE and LTM technology, which is what Tailguard operates on, and some of the other alternatives that exist out there, like land-based devices and systems. And finally, we'll talk a little bit about the Tailguard lineup on the commercial fire, a little bit on the Berg and the residential space. We'll cover it all, but are really just kind of focusing a lot on the commercial fire space, because a lot of the regulations and the codes are more strict on that end of the spectrum than they would be on the residential side. So there's a lot more to cover when it comes to the commercial fire space. So who is Tailguard? Tailguard, we were founded back in 1986, so it has been quite some time since we started in the industry. We were one of the first in many aspects as it relates to the communications industry, for the alarm and for the life safety space. 1999, we came up with an analog device, very basic, very simple, very straightforward. Those were the days of simplicity, right? Where you would have a panel, a security system, a fire alarm control panel that was meant to communicate in an analog format, basically dialing stuff in. Back in those days, we actually had analog cellular communication devices, because back in the 90s, it was still available. So we would actually take analog systems, open up an analog pathway, and deliver the signals in an analog way to the central stations. It was not an easy setup on the device side, but it was an easy transmission type, because we were matching analog to analog. So it wasn't a translation that needed to happen. Well, that all kind of changed in 2008 when the FCC basically said, hey, no more, we don't want this analog technology anymore. There is a better and more secure way of doing things, and that is the digital era. So in preparation for that digital change, Telga released back in 2005 our 2G units. With that digitization of the cellular industry and the cellular pathway, came a couple of different problems. Now we're still dealing with panels. We're still dealing with panels that were designed to work with analog connections. But the cellular pathway, it's no longer analog. Now it's a digital pathway. And that is where you can get into a couple of issues, a couple of hiccups. I'm sure that if you've dealt with voice over IP lines in your residential or even the commercial space, and having to have an alarm system deal with voice over IP lines, even though they have the look and feel of a regular phone line, they are digital pathways. When you use a voice over IP line, there is an issue where you may run into situations where the voltage is not correct, or where the message gets garbled up just enough to where it doesn't make any sense on the receiver side, so the central station doesn't acknowledge, and you have to have a second retry or a third retry before something gets through, right? And that is because you have an analog system trying to work with a digital pathway like voice over IP. That same type of issue existed back in the 2000s. So what Tailguard did is we decided to go towards a dialer capture system, in which we understand the analog way that the panel is working. We understand how it wants to communicate. We digitize that information so that it can be sent over the digital pathway, which is the cellular technology, and eventually get to the central station. So from then on, really, we just kept moving on with the time. So with technology that evolves, 2010, there was an opening. Finally, an NFPA code. The smart folks at NFPA recognized that technology was evolving, that it wasn't all about just having two phone lines, that what is considered a phone line is slowly fading and changing into something else. So they needed to have another way of allowing other technologies to come into the picture, right? So in 2010, NFPA 7.2 opened up the doors to have an alternate pathway, an alternate technology that, hey, as long as it meets specific requirements, hey, you can use that as your sole path. So in 2010, we introduced the TG7FS, which was one of the first commercial file communicators to be UL listed as a sole path device, basically replacing two phone lines. Again, from then on, we went to the different sunsets, came up with the 3G version, the 4G LTE version, and where we are today in the commercial space, we have for a couple of years now our 5G LTM technology-based units, which is something that I will touch on a little bit later in the presentation. There's a little bit of a mystique, or a little bit of not secrecy, but misunderstanding as to what 5G LTM is, and hopefully we can clear some of that up for you during this presentation. So the Telguard system is very straightforward, right? What we do is we take systems that were originally not designed to communicate over cellular network, and we take them and we make them communicate over a cellular network. Using our Telguard Communication Center, our data center in the middle, we're able to not only deliver the signals digitally, but we're also able to add extra features that allow us to not only meet code, but provide a better user experience. So what is the problem with POTS? The problem that we face today? Well, the number one problem is the technology is super antiquated. Technology has been around. The basic form of that technology, the twisted pair, 2 wires, tip and ring, at its core, it has been around for a very, very long time. The concept itself has been around since the 1900s, even earlier than that. Unfortunately, right? Fortunately and unfortunately, it has worked great for a long period of time. So, which is a good thing. You know, you want a technology to be there for you, to be reliable, to be consistent, but it's worked so good for so long that we've kind of just gotten to the point where we have relied on it for so long that we're not seeing the signs that are happening, or we are seeing them now and we're reacting to them, but these are signs that we should have seen many, many, many years ago. So how does it plain old telephone system or POTS, how does it work? Well, the call is basically routed through what we call switches. So a better example would be something like the picture you see in front of you, right? If I make a phone call to my mom, this is an example that I always give, right? If I make a phone call to my mom, she lives in Miami, I live in Atlanta, we both have, standard landlines. I have AT&T, she has AT&T. If I make a phone call to her, there is absolutely zero chance that the call coming from my end, going into her house from Atlanta to Miami, it hits only AT&T switches and AT&T infrastructure all the way through. It just doesn't happen, right? What actually happens is that along the way, as the call leaves my house and it makes its way through the network, it's going to hit different switches. Some of them could be owned by AT&T, by Verizon, by Quest, by many other carriers that own these switches. And within that, they're going to find a path to make the connection to the endpoint, to my mom, right? So if I call today from an AT&T to an AT&T, there's a very good chance that I'm not going to hit AT&T all the way. So what happens when there is a problem? What happens if I can't connect to my mom? If I'm having an issue with distortion, I can't hear her, who do I complain to? Well, I'm making a phone call, right? I'm thinking it's probably on my end. Let me call AT&T. Hey, is everything going well? Is everything okay? I had an issue. They can come back and tell me, yeah, everything's fine with that network, sir. I took a look at where you are, and there are no issues. All right, maybe it's my mom's side. Let me go ahead and call on her behalf. Make sure that her side of the fence is all good. Call up AT&T. Hey, my mom is at such and such address in Miami. Is everything okay? I've been hearing a lot of distortion as I make a call out to her. I was like, no, everything seems fine. We checked all our services and everything is good in that area. The reality that we face, and I'm sure if there are any central station operators here watching this webinar, you'll 100% understand this. A lot of the times, it's not the person that initiates the call. It's not the person that receives the call. A lot of the times, there's some kind of issue somewhere in the middle with one of those switches that happens to not be owned by AT&T or any of the carriers that you pay your money to, right? And that is what we call like a different end of the transition. So we talk about a front end transition. We try to transition things out of the network. We try to transition things out of what they are. So the front end is basically I'm looking at what I pay my bill. So I pay AT&T for a phone service. Well, guess what? I'm going to transition it into something else. You as an owner, you as the person that picks up that bill and pays for it, you have the power to do that. You have full-on access to control that front-end transition. You want to go to a different carrier? You are more than welcome to, as long as it's within your contract, of course, right? You are more than welcome. So you have a say in what the front-end transition is like. The back end transition, what happens in the middle with the different nodes and the different switches, that is something that you really have no control of. You can only control the carrier that you go with. But the switches in the middle that they have to go through to make phone calls, you have zero control over that. So when an issue happens and at one of these switches, one of these nodes, something breaks or they make some adjustments or they digitize some processes there in the middle, you really have no say as to what's going on there. You have no way of fixing it. You don't have the leverage that you have with that front end, with the person that you pay the bill to. So that is kind of like the problem that we're facing right now. We can only control the front end side of things. The back end is the part that we have little to no access to. And what is actually happening, right? I talked about pods being a reliable technology for so long that we kind of take it for granted. Well, it's gotten to the point where natural aging of things is taking its toll on POTS technology. Copper wire installation is old. And truth be told, it's prone to failures. It's always kind of been prone to failures, but it's always kind of worked for us. Well, now you have cables that have been buried decades ago, right? They're starting to malfunction. There are rural areas where things, rural areas get flooded, and all of a sudden the copper wire starts shorting out and you start losing phone connectivity. You have areas where there's construction and somebody goes ahead and chops up one of these copper wire lines. It's not as easy to replace as what you would think, because of the way the technology is evolving, right? You're for years, I'm sure you've gotten not harassed, but offered by your cable company, bundle deals, to 2-for-1, triple play, you can get a internet, cable, and a phone service. All of these are digital technologies that are coming up, right? And they're basically bringing in money for these businesses that are offering it, but they're not relying on phone, old-fashioned, plain old telephone service. They're relying on newer digital technology that is really built to give you voice access. It's not built for the industry. It's not built to deliver fax information. It's not built to deliver modem type information or alarm information. It's built to deliver voice quality, right? Enhance the voice, enhance the background noises so that it minimizes it, things of that nature that are built for voice connection, not so much for data transmission. So a lot of these technologies that are coming up and are flooding the market, well, what's happening is slowly but surely, manufacturers are sort of seeing the writing on the wall, and they're basically saying, hey, POTS technology as it is, all these analog systems that I used to support, they're going to start being changed out for digital systems. They're going to start being changed out for brand new, different equipment. As a supplier of these analog systems, what do? Do I wait it out and try to squeeze every little bit of juice out of it by continuing to supply my analog type product? Or do I actually do a more reasonable thing and pivot? You know what? It's a dying technology. There's a new technology that's emerging. This was 5-10 years ago, right? There's a new technology that's emerging. Let me go ahead and pivot to provide equipment and supply services to this brand new technology. So what does that leave all these owners of these switches in the middle and the nodes and everything that makes a phone conversation work in an analog world? Well, it leaves them with no parts to be able to repair these systems. It leaves them with an option, right, to where they either A, figure out a way to make it work, or B, they don't make it work. They figure out a way to replace the analog systems with a digital box, a digital conversion in the middle, and kind of say that they're making it work. Or C, just completely stop and say, you know what, we're not doing it anymore, right? Part of that wasn't allowed before. Part of that was actually sort of stopped, if you will, from a federal level. So there was an FCC order that basically said, hey, for the next 3 years, and this was back in 2019, you need to be able to provide a certain level of service, and you need to be able to provide it at a reasonable cost, and blah, blah, blah. Long story short, a federal mandate essentially allowed these users of the analog service, or the quote unquote analog service, to continue to pay whatever they were paying. and whatever extra cost that these carriers, that this middle of the last mile, middle of the switch carriers, what they would do is they would basically choose to either eat up the cost or figure out a way to make do with what they have so they can provide the service that they owe their clients. Well, the regulatory order, it basically said from 2019 to 2022, this is the period that you need to comply. After August of 2022, now you have other options. Your options are, hey, you can choose. You can choose to continue to provide the service, but now you're not price capped. Now you can actually charge a little bit more. And what happens is the person or the entity that owns that switch, that say an AT&T or a Verizon is using, right? They will actually charge more for that service because it costs them more to keep it up. And in turn, AT&T or Verizon or whoever that you pay for your service will have a decision to make. Do I eat up the extra cost, have it cut into my margins, or do I just go ahead and put on the cost back to the customer by increasing my prices? The latter is actually what's happening, what's been happening since last year. And I'm sure if you talk to some of your commercial customers and they start looking at their invoices from last year to today, they'll see a noticeable difference. There's a very noticeable difference in the way that pricing has gone. That's not the only sort of regulation that has kind of changed the scope of where we are today. There's also other regulatory changes, here and there that are basically allowing these businesses that used to support the switches and support the analog way of sending data, of sending voice calls, right? Basically saying like, hey, we're making it easier. We know that technology is changing. Not only can you charge more, but now you have an easier time. If you choose to get out of that business, all you have to do is give us ample time, provide an alternative, and you can get out of that business line, right? So it's just making it easier for, number one, the vendors, the suppliers of the service to get out of that business altogether, to change it to a more digital way, or to charge more for that service. At the end of the day, what that translates to is the people that pay these companies, the people that pay the carriers for the service, are looking at a higher bill or a lower quality in their communication pathways. Now, from an NFPA perspective, this is all being noticed, obviously. Public input, second draft, actually, it just happened about a week ago, I believe, in Kansas City. So a lot of this stuff is being talked about. It's going to eventually make its way into the code. We already have the code that changed a few versions ago, to where instead of requiring 2 phone lines, right, now it's requiring one. If you have one phone line, your second connection needs to be something different. It needs to be a cellular device, needs to be a two-way radio, needs to be an internet, needs to be anything else that performs in a way that meets the requirements. But you can't really have two phone lines anymore. As code usually goes, that it takes a while for it to be adopted by different jurisdictions. But over time, NFPA code is actually changing. It's actually adjusting to the realities of today, which is POTS is not reliable, POTS is getting expensive, and it's creating a situation in which customers are being forced to look at different options. The number one thing that I want to get from the POTS situation is that there is going to be a conversation. There is going to be a conversation that's going to be had about these phone lines increasing in price or degrading to the point where they're just not good anymore, right? As integrators, as security dealers, we need to think about where this conversation is being held. Is this conversation happening between the property manager and us, between the homeowner and their security dealers? Or is the conversation about what do we do about this phone line that's just getting more expensive, of getting crappier over time? Is that conversation happening between the property owner, the homeowner, and another service provider, in an AT&T or a Verizon or a Magic Jack or whoever else that can offer you a digital service that, quote unquote, has the same feeling as a voice line? Are we, as integrators, dealers, people from the industry that care about the safety of our customers, about protecting property, protecting life, are we being included in that conversation? Chances are we're not. Chances are you have telemarketers calling them up and offering those deals that, hey, I know you're paying more for your phone service now than you were last year. here's what I can do for you. I can save you 30, 40, 50 bucks. Just go with my digital system. And what's going to happen, because that same type of phone line is being used across the board, you may actually have a failing system a week later. Or what's worse, you may have a system that attempted to deliver a signal and it didn't, because it didn't work properly under the new voice over IP or whatever digital pathway. So one of the things that we need to keep in mind is that these conversations about replacing expensive or degrading phone lines are happening. We need to find a way to get in those conversations, to be in the middle of it, to help our customers understand what's at stake. And it's not an easy thing to do, right? There's a lot of communication that is readily available on Google, on your standard web browsers, right? But information nowadays is different. That's something that you could relay, 10 years ago. The right or the wrong keyword search will give you all kinds of options that to a homeowner could be overwhelming. To a property manager that is not 100% understanding of what ULA 64 is, right, could be overwhelming. Could be, I don't want to say deceiving, but could be misinterpreted, right? So we need to figure out and find a way to get into those conversations so we can advocate not only for obviously our recurring revenue, right? Not only for the RMR, so we can get some of the RMR, but also for the safety of our customers. So when we talk about cellular, right? Cellular has always been an option for Tailguard since inception. Since the 90s, it's been a part of the industry since the late 90s. And Tailguard, again, has had product lines with, analog amps, 1G, 2G, 3G, LTE, and now we are on the 5G LTM network. So the evolution of cellular technology, it's sort of an evolution similar to supply and demand, right? When you think about supply and demand, it's the more you demand, the more your customers demand, the more you have to supply, right? The more you have to build to satisfy that demand, that craving. It's a similar concept for cellular technology. When you get a taste of what you have, you start thinking about what else can you have. You start demanding more things. From the network perspective, if there's more demand for some of these products, guess what? I'm charging by the data. So let me go ahead and make it so that you can consume more data. Let me go ahead and increase my capacity. Let's evolve the technology so that at the end of the day, I can sell you more. So that at the end of the day, cellular becomes not something that it would be nice to have, but something that is weird if you don't have, right? And that's kind of like the way the technology and the networks and everything has evolved. So over time, it's been about what more can we do. So with the 1G, it was all about voice. With 2G, we started introducing messaging, SMS. With 3G, it was all about data, trying to introduce more data. With the iPhones came into the picture, the Androids came into the picture. Then we started looking at how, with 4G LTE, how do we make it so that you have a seamless experience, right? Your internet at home and your internet on your handheld device. How can we make it so that you can distinguish between the two, right? So that you can do what you can do by being plugged into the Ethernet at your home, the same thing that you can do by wirelessly connecting to a cellular network. And that is what LTE was kind of all about. Once we start getting into what the 5G network that's coming into the world today, it's really about what more can we do? How much more, how much better can we be, right? Yeah, you can stream Netflix, but can we stream 8K quality Netflix through a mobile device? Can I actually replace, right? Instead of being on par with your cable access, your DSL line or whatever, can you have a mobile hotspot that will actually replace that and give you better performance? And again, it's all about cellular networks being able to sell the data, sell more data by providing you with better access, better data throughput, right? So all of this is really targeting, again, the end user, your Android user, your iPhone user, your tablet users, right? Those people that are going to be streaming things, that are going to be looking up things, checking emails, and doing all kinds of crazy things, streaming music and all of that. But as we start getting into data availability, right, we also start looking at the concept of Internet of Things. And I don't know if you're 100% familiar with it, but at its very basic core, it basically means things that you weren't able to connect before, now we're making them connect to one another. I give the example of a light bulb, for instance, right? 15, 20 years ago, you went to the store to get a light bulb. You had a couple of choices: fluorescent light bulb, incandescent light bulb, maybe the soft white, powdery kind. But that was about it, right? A light bulb was a light bulb, different wattage and different things, lumens, but a light bulb was a light bulb. You go to Home Depot today, or Ace or Lowe's, and you're met with a variety of different light bulb, Internet of Things capable devices, right? You have your Samsung LED lights that will connect to the Wi-Fi, allow you to change colors, and you can control them with an app, or you can control them through a different application that integrates into your iPhone, and all these kind of different things. So a light bulb is no longer just a light bulb, because now it's part of the IoT world, Internet of Things. And now you can think of it as a device that can be controlled in some kind of way. So that's what IoT world is. It's controlling devices that don't require a person necessarily to be there. And this is actually where the technology that we use today comes into the picture. LTE-M. LTE-M, 5G LTE-M is a technology that Telguard has chosen for its future. And a lot of it has to do with the way that it was designed. So LTE-M, M stands for machine to machine. And it was specifically designed to cater to these IoT devices, to cater to the IoT world. It wasn't designed to cater to the iPhone and the Android guys. It wasn't designed to cater to the people that are going to be streaming 4K quality video, 5 hours out of a day. It wasn't meant for those guys. It wasn't meant for the people that if you have bad signal in one area, you can simply walk out and go walk somewhere else to get a better reception, right? It wasn't built for those. It was essentially built with a mindset that I am building for a device that is going to be standalone. It's going to have specific requirements that are specific to that particular industry. When we think about our industry, the intrusion side or the life safety, what do we want? What do we really want? We want good signal. We want reliability of that signal. We want to make sure that it can the building structure, so they don't have to fumble around with external antennas and things of that nature, because we know the nature of our business, the nature of our installations, right? If you live in the intrusion side, you know that panel is going to be as deep within the house as possible, as many walls from the outside to get to that panel as possible. That's just, it's just the way that installations are done. Closet deep in the house, or a basement, or somewhere where we can put as many walls as possible between an intruder and a security system. That's, installation 101. But what happens when you put that many walls or that many layers? Well, you're kind of decreasing your chances of getting a good signal. Well, take that into account. Let's go ahead and design LTE-M with that concept. Let's make sure that we have good in-building penetration using whatever technology we decide to use. All right. We also know that these devices need to be low power, right? Because you're not going to be charging them up. You're not going to be moving them around. So there are certain features that are catering to these devices that are going to be standalone. Some of them are going to be running off battery for a long time. You also have the number one thing I would say, besides reliability and an ability to get signal strength, is that you don't change these devices at the same frequency that you change your iPhone, right? I'm guilty of changing my iPhone pretty much every year. I'm one of those guys that would figure out a way to do it, right? And most of the people out there are changing their iPhones or the Androids every couple of years at worst. Companies, networks, AT&T, Verizon, T-Mobile, Metro PCS, whoever, they're basically giving phones away to get you to change devices. So we talk about the sunsets and the 3G sunset and LTE sunset and all of these things that are happening or that will happen in the future, right? These carriers, AT&T, Verizon, T-Mobile, they're well prepared for it from an end user perspective, because they've been giving phones away for years to push those boundaries so that those customers that were limited to how much data they can consume because they had a 3G phone, right? Well, guess what? Let me give you a free LTE phone so you can have a better experience. They are going to have a better experience, but they're also going to consume more data, right? So from that perspective, they're very well prepared, and there's an expectation in the market from an end user perspective, from an iPhone perspective, that you're going to change it every year, every couple of years. From a perspective of a communicator in the intrusion and the firewall, right? From a perspective of take the communicator out of it, of a system. If you install an alarm panel, if you install an alarm system, the expectation is that you're not going to be changing it out every couple of years. The expectation is that once you install it, it works. It works for your customer without issues. It works for you without having to cater to it or service it every so often. You collect revenue, your customer is happy, and that's the expectation. That's the ideal situation, right? What's been happening with the cellular world is that because we have been sort of piggybacking of the end user side of things with the 2G and the 3G and the 4G, all of them kind of designed to enhance the end user, the iPhone, the Android experience, that we've actually kind of been having to overcome those sunsets by replacing them. With LTE-M technology, that was taken into account. And one of the really big things for us is that it is considered a 5G technology. The biggest thing, though, is that within that 5G technology consideration, I guess, if you will, it will transition from LTE, from using the LTE footprint, which it does today, to using the 5G technology when the time comes to transition over. So that's the good thing for us in the industry, because what you're looking at is an ability for this technology as it's prescribed today to more or less bypass the next sunset. Now, there is no indication that LTE is going to sunset in the next 5 or 10 years. We're maybe looking at, I don't know, 2035, 2040, who knows, right? But whenever that is, whenever that happens, the technology LTE-M is prepared from a network perspective, from a device perspective, to transition to use whatever the next thing is. In this case, we know that it's 5G. 5G as it stands today, it doesn't have great coverage because of the way that it implemented its network, because of the frequency ranges that it uses. But whenever it gets to the point where it can be a standalone technology, LTE-M products, LTE-M devices will be ready to transition along with it. And that's the beauty, at least for us in the industry, something that we haven't had before, something that will serve a real purpose to continue to provide service and collect that recurrent revenue without having to worry about, servicing or reaching out to a customer with that notification like, hey, I have to change your unit, even though I just literally installed it 5 years ago, right? Yeah, your panel, yeah, I know it's been working great, still working great, but that one piece of equipment, I got to change it now. That's the beauty of LTE-M, that you won't have to change it. So one of the things that we've always had, it's a LAN option, LAN alternative, right? If you're not familiar with LAN versus WAN, it's pretty straightforward concept. Wide area network is the internet. LAN, local area network, is basically how you get to the internet, right? From your house, from your office, how the inside of the building, the inside of your house, that is your local area network. And there's pros and cons to it, right? Number one, it sounds like a great option. It's readily available. It's inexpensive because chances are you can just share bandwidth. And let's be real about it. The type of data that we can consume from an alarm system, it's very, very minimal. It's very, very minimal compared to anything else that anybody will do on the internet. Checking an email probably takes more data than it does to transmit a single contact ID signal, right? So it's a readily available connection. It's a fast connection. But when we start looking at the cons for it, right, it's a shared connection. It's managed by somebody else. It's a locally managed network. And that is probably one of the bigger things, the fact that it's a locally managed network, which means that from an installer perspective, from a selling perspective, right, it sounds great, but now you're having to ask people to let you into their network, depending on the type of entity that you're dealing with, right? A house in a residential space may be a lot easier to get in, whereas opposed to like a financial institution, you may have to jump through hoops to even get in there, or you probably be told no, right? Besides that, assuming that you get to that point where everything is great, there's still a dependency on extra equipment. Now you have a router to worry about. Now you have a cable modem to worry about, or something else to worry about that unfortunately is not within your scope of maintenance. So you can't really control, where that goes. or how it's powered or the backup systems behind it or anything along those lines, because it's locally managed. So there are pros and cons to it. Our assessment as Tailguard is that it is a great redundant path. It's a great second line. But for Tailguard, what we do is we provide it as a dual path option. And it's worked out very well for us, because on the number one thing is when we have those conversations with those end users, with the customers, right, that have hesitation about firewalls and things of that nature, our answer is yes. Our unit will use the internet, but it's an outbound. Anything that needs to get into that panel, into that Tailguard unit, we have the cellular pathway always available, because we do dual path, so that we don't have to get in through the network. We just need to get out. It's an easier conversation to have with your network savvy folks. Number two, if anything does go wrong, let's just say you're working fine for the first 3 months, all of a sudden somebody gets on the router and sees, hey, I don't recognize that MAC address. Let me go ahead and just clear it out. Something happens. Let me go ahead and block it. Something happens. You're always going to have that cellular connection available to be able to back it up on something that was out of your control and it was locally managed. Another scenario, somebody goes in and says, hey, I don't recognize that IP address. Let me go ahead and reset the router and reassign it a brand new IP address. Well, we don't have that information. We had an old IP address. We don't recognize that anymore. What do I do? Well, it's a simple fix. All you got to do is change the IP address on that radio so that it recognizes the new one. I'm like, okay. We can do it remotely because Tailguard still has access to that particular device over the cellular network. If it was an internet-only device, we would have lost connection. And what does that mean? That you have to get over there and physically do something to make it better, right? So there are pros and cons. From our perspective, we just feel strongly that, while internet is a good technology to serve as a communication pathway, there is still something to be said about having that cellular option backing it up to be able to take care of issues. NFPA 7.2 compliance, I mean, it's all pretty much part of the code. Commercial firewall compliant, provided that we meet specific requirements. The requirements kind of change from edition to edition, but something that hasn't changed since 2013 is the fact that for communication pathways, if you're doing a sole path, you have to have some level of supervision. You just have to have some level of supervision, whether it's 5 minutes or 60 minutes. 60 minutes has been the norm since 2013. But that is what basically makes you compliant with commercial fire code. The way that we do link supervision is pretty straightforward. We basically just enable the device, the Tailguard unit, to be able to send pings back to the home base, if you will. And we're going to monitor these pings to make sure that the unit is communicating. And whenever it doesn't, we're going to time it. And if it meets that gap of 60 minutes, we have to alert the central station. So we're using the data center, our data center, as a way of more or less policing that the device is readily available to actually transmit signals. And that's what gives us the option to be able to be a sole path communicator. Something that I wanted to point out is that we do have an inspection checklist in our website, and it kind of walks through the different things that anybody would need to check as they go through an inspection from an AHJ and inspection perspective. It just gives you a quick rundown of what to do, what to check for, very much without having to know how to install the product. So this is something that we offer HJs and inspectors to say, hey, I know you deal with a lot of different communicators, different brands, different models. You may not know Tailguard as well, but if you follow these directions, take a look at the lights, read off and time it appropriately, do what we tell you, you'll be able to check off that everything is working as expected, as manufacturer recommends. So the commercial fire lineup, just to kind of close it out here, we have about I'm going to say 4 different communicators and a very, very important accessory, which is a TG pen. So let's get started with the TG7FP. This is the most affordable communicator, and it's basically taken a very basic need for sole path communication, a very basic approach to if you can handle a device being connected onto your panel for power, and you need a sole path communication pathway, TG7FP is what you need. It's a most economical, most affordable product. And the only caveats are that it needs to power from the panel, will take 10 to 30 volts, and it can only do soul path. If you need something a little bit sturdier, you need to have options, right? The TG7FS gives you those options, and it basically gives you whatever the TG7FP has as far as features. It can it can power from the panel. It can do the soul path, but it can also do a backup with a telco line. It can also power off an AC and battery connection if that is more desirable, if that is what's available. So it gives you the option, and it's also TG-PEM compatible. The TG7FE is one of our newer products. And again, it just basically adds a dual path option that I was mentioning. So it gives you the same options as the TG7FP as far as being able to be soul path, being able to power off the panel. It still gives you that AC option, and with a battery backup inside of it. It gives you the TG-PEM compatibility. The big difference between the FS and the FE is that the FE unit actually provides you with a LAN option to where you can connect to the internet as your secondary pathway, as opposed to the FS, which still gives you the telco, the POTS option as a backup. And lastly, the TG-PEM is our accessory that gives you the option to do multiple inputs, which actually comes in pretty handy, particularly in the firewall, because it is ULA64 listed like all of our products. But it gives you the option to do multiple inputs from a panel, and it translates those inputs into contact ID messages to be delivered to the central station. So what that actually does is it can take outputs from a panel. So think of outputs like fire alarm, supervisory, and trouble, takes those three outputs into the TG-PEM, connected to a Telguard FS or an FE radio, and we can translate those outputs into contact ID messages that will deliver those fire trouble, fire alarm, and fire supervisory events whenever they open or close. So it's a very quick and dirty way to get even those more antiquated panels. So Telguard is universally known as being able to handle the most amount of formats out there: contact ID, SIA, DMP, radionics 2, 3A square, modem 4, Sonotro format, Pulse 4x2, 3x1. So we can handle all of those formats. But there are some panels out there that are still, knocking around 40, 50 years old, some BFSK stuff, some of the FBI systems out there, right? That we can still communicate with, not with the actual dialer capture that we're used to, but we can actually use the outputs for those systems to create contact ID signals that will translate and will be delivered to the central station. Lastly, we have the TG7UB, and this is more of a board that will replace an old board. So if you do come across a situation in which you have an old 3G unit, or you need to change carriers from an AT&T to a Verizon, right? This is we're just basically giving you the board itself. As long as you have a Telguard chassis available, it'll be 100% ULA64 listed, and it'll give you the same exact features as a TG7FS. So with that, pretty much wrapped it up. I don't know if there are any questions, Daniela.
Hey, Daniel. Let me see. So we haven't had any Q&A questions come through. I guess you must have been very clear, concise, and specific, which is great. But no questions have come through yet. Is there anything that you want to touch up on, or maybe clarify before we log off?
I think just to kind of wrap it up, I mean, I don't think that I can emphasize enough, right? There is a call to action today, to have those conversations with our customers, with our property managers, with our homeowners. Somebody is going to call them up. It's the nature of American entrepreneurship, and what drives businesses, right? You see an opportunity to jump on it, you make money, right? The real question is, who's going to make that money? Is it going to be the cable company, the phone company, or whatever other devices being sold out there to serve that purpose? Or is it going to be us from the industry, from the life safety world, from the intrusion world? Is it going to be us trying to make that extra little bit of money, and at the same time protecting our customers from those other devices and systems that may not be compliant?
Right. We do have one Q&A question that came through, and it says, what is the impact of POTS to the residential segment?
I think for the residential segment is actually, it has already been felt. When we take a look at some of the statistics, right? Even if you just think about it from your own perspective, think about it from yourself. Graduated college, you get an apartment, you get a house. How often do you actually call somebody up to get a landline? How often do you demand a landline to be in your house? I actually never actually had a landline. I left my parents' house. My parents had a landline. I've always had a cell phone since leaving my parents' house. I've never felt the need for it, right? So from that perspective, if you think about that and you multiply it times the millions and millions of people in the US that are graduating and starting their own lives and getting into the home ownership world, right? A lot of them are not actually coming in with that need for a landline. So the opportunities for POTS replacement is not as big on the residential side. On the commercial space, however, there was a study that was done. About 30 million phone lines are still being used out there for commercial intrusion, life safety cases. So when you think about 30 million, that is a big number of phone services that are still being used out there. And a lot of these folks are going to be disgruntled with their bill. Whether they notice it today, they notice it tomorrow, eventually they're going to notice the increase. And that is when we got to jump on it, make sure that we have those conversations and make sure that we provide the type of quality service, whether it be Tailguard, one of our peers, or one of the approved and compliant, and most importantly, UL listed technologies, so we can provide a safe replacement for those phone lines.
Okay, awesome. Let me see. We don't have any more Q&As. So with that being said, we can go ahead and wrap up unless anybody has any other questions. But if not, thank you so much, Daniel, for such an informative webinar. Thank you so much for your time today. Thank you to everybody that joined and listened in on our webinar. We will be posting the on-demand webinar on ESA's YouTube channel, as well as our integrator newsletter. So thank you so much, and I hope you all have a great rest of your day.